So here is a volumetric pipette that is 25 milliliters. It was broken at the top, so I cut that section off, and from another broken pipette I cut a comparable section off. They're not exactly the same diameter, but the plan will be to fuse these two pieces of tubing together. Now in this case, the diameter of the tubing is about 7 millimeters in both cases. They're not identical, they're very close. So that should be sufficient. And I'll show this in a second. Rather than doing this by hand, I'm going to mount this using clamps and go from there. I'm going to repair that 25 milliliter volumetric pipette, and I'm going to use the hand torch. So right now I've got the piece that I'm going to fuse from a different pipette locked into a clamp. This is a specialized clamp that we use for holding thermometers, and the body of the volumetric pipette is in this larger clamp. You can see down here at the bottom, this is a little bit of paraffin, and what I'm going to do is I'm going to hook up my blow hose here. I had to add this paraffin because this is about 7 millimeters, and this is for about 9 to I think 11 millimeters. So this is too small to fit into the silicone. And as I do this, I'm going to be using the hand torch to make the seal. And so I'm basically going to put these two pieces of glass tubing together, have them in proximity, and then go ahead and make my, my straight seal or my butt seal that way. And the reason I'm doing it is if I try and bring the glass tubing together like this, the way you normally do it, I am very worried that because of how small this diameter is, 7 millimeters, that I'll get it off center and just make a mess of it. So rather than do that, I'm essentially going to get these two pieces of glass tubing in contact with each other while they're cold, tack them, and then go from there. And one of the things that might become an issue is, well, if I have an air gap, in other words, if I have a bubble between these two pieces of tubing, what I can do is I can come in, this is 3 millimeter rod, I can come in with the 3 millimeter rod and add a little bit of extra glass. Or, if I need to move some of the glass, I can use my tungsten pick. So this is actually how I started doing glass blowing, where I would have a hand torch. The work would be stationary, where I would have it, secured with clamps, and then I would come in with the hand torch and do what I needed to. So this is a perfectly valid technique, and it's the kind of thing that some labs you only have a hand torch, so you don't have the ability to use, the bench burners like we've got here in my research lab, like these really nice torches. So this is a case where because of what I'm fusing together, I'm going to go ahead and use my hand torch and hold the work secure. I'll be able to blow through the bottom, and hopefully that'll give me good results. And by having everything clamped up and aligned, I should be able to keep this straight throughout the entire process. Once I do have this fused properly, if I do need to make any adjustments, I can always take it out of the clamp, go to the bench burner, heat this, straighten it out, and go from there. I've loosened the clamp on the top, so that way this glass tubing is essentially falling downwards towards the body. That should help fuse them together. if I had the top tubing very tightly secured, when I start to heat this, they're not going to fuse together. They're going to actually move apart from each other. So that's something that, if I can, I want to minimize that. We'll see how that goes. So now I'm adjusting the hand torch, and I'm going to just start off by going around, warming that up. I haven't put my blow hose in my mouth yet. I'll do that in a moment. Really what I'm going for right now is just to try and get a stick, basically get these guys fused together. I'm testing with my blow hose right now, and when I puff into it, it's definitely a seal, so that's a good sign. I made what was almost a comical mistake, if it wasn't so serious. My blow hose got kinked off camera, and as I'm blowing, I'm wondering, why is the glass not moving? And it's because literally my blow hose had a constriction. So again, now I'm going to actually rotate the piece. See how we're doing here. So the downside of using the clamp is, I think a little bit of the torque from the clamp has pulled the tubing a little bit off center, but that's okay because that's something I can fix later on by just going to the bench burner and then heating and rotating, because really what I'm looking for here is to make sure I've got a good uniform seal. In other words, that it's a hot seal, not a cold seal. So that's why I keep alternating, heating one side, going to the other, and rinse and repeat. Let it collapse a little bit. Pump it back out, and go from there. At this stage, I have successfully fused this small piece of tubing onto the body, but you can see it's not centered. So what I'm going to do now is, on the bench burner, I'm going to gently go back and forth and heat this area, and then just using rotation, I'm going to try and straighten this out a little bit more. I have to be really careful. I don't want to heat down here and distort that, because then the pipette becomes useless. By the way, I was always going to come back to the bench because I haven't fire polished this. Also, I've still got the blow hose attached, so as I'm heating this, if I need to, I can puff into it. But I'm really going to just try and make a very small adjustment to try and get this so that it's straight. It's got a wobble in it right now, which is not terrible, but certainly I can definitely do worse. Hopefully I can do better. And I should also mention I'm using a very soft flame where I've got a lot of fuel in it. I'm not going to crank it up and use that very rough annealing flame because of how small, how delicate this is. So in straightening it out, I got a little bit of a constriction right here. However, for the function of the burette, that won't impact it, and I can confirm that by testing it. But it's a little flat spot. But straightness it's good. This is the issue of using this, again, very thin or very small diameter tubing, and just a little bit of heat will cause it to deform. And I don't want to blow it out too much, so I'd rather have it caved in a little bit relative to blown out, because once you blow it out, there's nothing you can do about it. So at this point, I'm going to say this part of the repair is done. I need to fire polish the end, so that's pretty straightforward. That. And see, look at that. I spoke too soon. Once I started fire polishing it, it actually caused that to crack. So I'm going to have to remove that section of glass. I'll just go ahead and fire polish it for safety. You can see, yeah, that's a problem. So this particular glass that I used, it's got a lot of stress in it, and so as I'm doing something which is trivial, fire polishing it, I've now made it worse. So that's something I can fix, but something to, like I said, be aware of. In other words, putting more heat on it at this point is not going to make it any better. So what I'm going to do is I'm going to cut that off, and then manually with a file polish it down, remove the sharp edges.